Hi everyone, and welcome back to Mr. Hunter's physics lessons. We're going to go through lesson 2 of the quantum physics topic in year 12, the photoelectric effect, and this is for chapter 13.2. So again, let's just jump straight in. What is the photoelectric effect? Let's draw some diagrams to get us started. So I'm going to go for just a box. You could be drawing this, or should be drawing this with me. There's my box. I'm going to label this as a metal. And in a metal, because of the lattice and the way large metallic bonding, we've got free electrons in the lattice, and therefore we can have little E minuses dotting around, little electrons that are free to move within the metal. We're going to take some photons, and we're going to shine photons upon the surface of this metal. And I'll just put, for the moment, EM radiation. And what we'll notice is that these electrons here, they fly out of the metal surface. We have electrons coming out. So these electrons here are labeled as photoelectrons. And so they obviously have got something to do with photons. They aren't photons, and they aren't any different from normal electrons, but they are electrons that have been emitted because the electromagnetic radiation allows the electrons to be freed, i.e. the electrons will absorb the energy provided by the photons and allows the electrons to escape. And so let's do a little bit of mathematics, and from last lesson we saw that the energy of the photon is equal to hf, so it depends only on the frequency. And let's say that you shone some red light onto this metal block, and no electrons came off the surface. Well, that means that those photons did not have enough energy to free those electrons. So clearly there is a threshold frequency. And so if, let's say that you shone blue light onto this surface and you notice some electrons came off, then you would know that blue light, i.e. it's a higher frequency and therefore higher energy, that those photons would come off and it would meet the threshold frequency. Okay, so let's do some notes here. So I put, in order for photoelectrons to be, emitted, threshold frequency must be reached. And so it's important to note here that if threshold frequency isn't met, no electrons or no photoelectrons will be emitted despite the intensity magnitude, or despite the magnitude of intensity. So it doesn't matter how many photons you have shining upon that surface, You could have an infinite number of photons shining on that surface. If none of them have the threshold frequency, then none of the electrons would be emitted. And so there are a few more takeaway points from this, is that the electrons from the surface are they are emitted instantly. So I'll put photoelectrons instantly if threshold frequency met. And the last point that we need is that if threshold frequency met, increasing intensity does not increase Ke of photoelectron. And that makes sense because the energy of the electron that's being emitted, i.e. the kinetic, once it's been freed from the surface, it doesn't matter how much more photons you shine on that surface, each electron is absorbed by a single photon. And so if you increase the energy of the photons, the photoelectrons that are emitted will have more energy. But if you don't increase the energy of each individual photon, you just shine more photons, i.e. you have more intensity, then that doesn't actually increase the kinetic energy of the electrons that are emitted. And so let's draw another couple boxes, I think. Actually, let's do it further down. And so I'm going to fill these boxes. These are the same metal. So again, these are metal and the same. Let's shine some red light onto the surface. So red photons here, and let's do blue photons on this one. Then we'll notice, let's say there was no photoelectron emission, and then you have lots of photoelectrons come out, or it is equal to the number of photons that you had come in. We have photoelectron emission. And that's because the blue light has met the threshold frequency. And so the threshold frequency, in order for electrons to be emitted from the surface, can be defined as the work function. So let's continue with our notes. The work function, and it's given the symbol phi, is the minimum energy required to free an electron from the surface of the metal. And so leftover energy goes into the kinetic energy of the photoelectron. And so this work function will be unique to the metal. And so again, let's draw another couple boxes. And let's have our electrons in here. And let's shine this. Well, I'm going to go from blue light that we had before. 1, 2, 3. And on this side, I'm going to draw some sort of ultraviolet light. And I'll put, let's put UV light, whereas this one was just blue light. And for this particular metal, let's say that the electrons come off. They do. One for each photon. But on this one, ultraviolet light has a higher energy than blue light, and therefore these particles will come off much faster. And so the distinction is that higher kinetic energy of the photoelectrons. Okay, so that concludes what the photoelectric effect is. And in the next lesson, we're going to look at the equation we can use to calculate the energies of these electrons that are emitted via the photoelectric effect. But this is the general principle of the photoelectric effect. So if it's been too fast for you, just go back and update your notes, pause the video wherever you feel like you need to. And we will cover the equations in the next video.